Okay, we're here doing series, and I believe this is lesson 5. Lesson 3 and 4 were done in class. So this is lesson 5, and this is the last lesson on series before we start talking about convergence. What we've been looking at is derivatives at 0. So anytime you are looking and putting derivatives, f of 0, then f prime at 0, then f double prime at 0, and I'm talking about like the ones we've did in class, but anytime it's 0, that has a special name. That name is Maclaurin series. A Maclaurin series is doing it at 0. Sometimes that's called centered at 0, because these series, okay, what you find out is that the graphs look very much like a W, or like a W with a lot of things like that, or an M with a lot of humps, okay? And in the center, we are centering it at 0. So that's where that centering comes in at 0. That's called Maclaurin. That also is the same as a Taylor series centered at 0. At 0. So when they say Maclaurin, they mean a Taylor series centered at 0. These guys are the same. Okay? They're the same. Maclaurin and Taylor series centered at 0. A lot of times with Taylor series, however, they ask you to go not to the first 3 non-zero terms, but they'll ask you to go to some degree. Remember that the degree is equal to the power. Okay? So if they ask you to give me a 4th degree Taylor series, then you're going to C4 and then getting the 4th power. Okay? So that's just some insight to know. Maclaurin is what we've been working with. That's exactly the same as Taylor centered at 0. Degree is the power. Today's goal of the lesson, our learning goal for today, is to do problems, okay, or to understand how to do problems. Understand how to find series not centered at 0. That's our goal. It's to understand how to find series not centered at 0. Or forget about you better understand it, but to find series not centered at 0. So let's try it. I have an example here. This is the new stuff. This guy is not centered at 0. It's centered at x equals -2. How do I know that? Because if I set this guy equal to 0, what's inside, I'll get x equals -2. That's where it's centered. All right? And let me show you how to do a problem like this. So, the algorithm pretty much stays the same. I got f of x equal to cosine of x plus 2. All right? And now if I am going to look at f prime, okay, f prime at -2. Okay? Or I'm going to, actually, the way I did it in class, you might like it better. All right? Now I'm going to do f at -2. That'll give me C0. All right? And that would be the cosine of 0, which is just 1. Okay? That's C0. Then the next one is going to be the derivative of f of x, which is going to be, well, sine, or I should say negative sine, my bad, of x plus 2. All right? remember that it would be negative sign, and then it's times the derivative of the inside, and the derivative of the inside, since it's x plus 2, is just 1. So we're okay with a chain rule here. So I am going to check out f prime at negative 2, and I get 0. That's our C1, which means we don't even worry about it. The next one, f double prime of x, is going to be negative cosine of x plus 2. Well, when we go ahead and we're looking at negative 2, that's where it's centered, all right? We are going to get negative 1. That's equal to C2. Then I'm going to go 3. I'm going to go 4 of them because I mentioned degree 4, so I might as well go 4 of them. So the third one is going to be just sine of x plus 2, which is a 0 term. Oh, wait. There we go. We're better. F out of there. This is 0. That's C3. And then C4, the fourth derivative, out of there, of x is just going to be back to the original, cosine of x plus 2, and then that's just going to be at negative 2 is going to be 1, and that's C4. All right? Well, we know that this is, the first one's 1. This is going to be negative 1 over 2 factorial, because remember, this is 2 factorial C2. This one is 4 factorial C4, so that's going to be 1 over 4 factorial. When I go and do the series, the only difference here, is we start with C of 0, which is 1. So this is going to be cosine of x plus 2, the series generated by that, is going to be 1. Then the next one we have is plus x plus 2 quantity squared over 2 factorial. Whoa, x plus 2, yes, because you take, instead of x, it's the power series centered at x plus 2, or negative 2. So it's x plus 2 as, instead of using x squared, okay, because that's what we would use, was x squared. Now we're using the whole where it's centered at, and that's negative 2, so it's x plus 2. Then the next one would be, you could predict, it's over here, plus x, the quantity x plus 2 to the 4th power over 4 factorial. So we use whatever the expression is for the angle as our x. This would be, remember, in Maclaurin, this was x squared, this was x to the 4th. Now with Taylor, depending on where it's centered, that's what we put there. Okay? Now let's see if we can get a general term. Let's see, I don't know. This is 0, 1, 2. So it looks like on the bottom is 2n factorial. On the top, it's x plus 2. Okay? X plus 2. No cosine in there, okay, because remember the power series only involves the x's, not the function. And that looks like it's going to be to the 2n. And it is alternating, because I did forget to make this a negative. Because if you remember, I had a negative here. So it is an alternating series, so I'm going to put negative 1 to the n. N equals 0 to infinity. Good? I hope so. All right, I'd like to do one more with you to get you, to make you feel good about it. All right, I don't know if I'm going to, but I'm going to try and make you feel good about it. So let's center something else somewhere else. I have an example here, and I'll erase it, and we'll do it. All right? Here we go. I'm going to erase all this stuff. All right, get out of here, because I'm going to do it. All right. So here's an example for you. I don't know what else is down here. Wow, lots of stuff. All right. So, sometimes the format, here, I'll rewrite this. Okay, there we go. That's not too bad. So it's going to say, generate the Taylor series of 1 over x at a equals 2. Well, if we tried Maclaurin and we put 0 in, it's all bad. So that's why Taylor comes up, because some of the functions are not defined at 0. all right, like this one. So we're going to, this is at a equals 2, degree 3. Degree 3 says where to stop, so I need to go to the third derivative. And it's centered at 2, which means that my expression is x minus 2. Cool? All right, if it's centered at 2, that means it's x minus 2. So, let's see what I can do here. I have f of x equal to 1 over x. So f of 2 is equal to 1/2. That's my c of 0. Then we have the derivative of that, which is negative 1 over x squared. And that derivative at 2 is going to be negative 1/4. Okay? And that's equal to 1 factorial C1, okay? So C1 would actually equal negative 1/4, okay? So C1 actually equals negative 1/4, all right? Now I take the second derivative, and now the second derivative, I get 1 over x, nope, I get 2 over x cubed. So I take the second derivative here, and I'm going to put 2 in here, and I get 1/4. And that equals 2 factorial C2s. So that's going to be C2 equal to 1 over 2 factorial times 4. Okay? One more. I only have to go to degree 3, so I only have to go one more. Okay? So it's going to be the third derivative of x. All right, and this is going to be equal to, I don't know, I need help here. All right, this is going to be negative, what, 6 over x to the 4th, I think. Help me? Yes, yes? Yes, yes. And this is going to be the third derivative is going to be at 2. 2 to the 4th power is like 8, that's 8 and then 16. So it's negative 6 over 16, and if I make that nice, that becomes negative 3 over 8 equals 3 factorial C3. C3 then equals negative 3 over 8 times 3 factorial. So let's see if I can put something together here as a, now it didn't ask me for the general term. I'll give it to you, and not all the time can you find a general term. But let's see what we got here. So we have 1 over x equal to, well, c of 0 is 1/2. So it's 1/2 minus 1/4, and it's times x minus 2, okay? Then it's plus, and this looks like it's just going to be plus 1/4, 2 factorial on the bottom of x minus 2 quantity squared, and then it's minus 3 over 8 3 factorials of x minus 2 quantity cubed. That's it. This is it. All right, let's see if we can find a pattern. I don't know. It might be hard to find a pattern on this. I really don't know if we're going to find one. So on the bottom, this was 0, it became 2. It's 1, it becomes 4. So if I do 2 to the this plus, and wait a minute. This is 8, and now I'm just figuring it out. Now it's just like the puzzle. So this whole thing is 8, and this, if I cancel with the 3, it's 16. So 0 to 2, 1 to 4, 2 to 8, that is on the bottom, 2 to the n plus 1. And then I'll do n factorial. How's that? That works. I guess I could get a little crazier, but this is what I have. 2 to the n plus 1 gives me this. Watch. 2 to the n plus 1 is giving me this number in front. Okay? Maybe it's